Hello.
Hi, Professor.
Hello. All right. As I was saying, homework was due last week, and everybody submitted. I see. Grading has just started. It will probably grading will complete probably by the weekend, so that you know well before next week's exam, and then you can review them. In terms of midterm exam is next week. It starts, it happens in class time. So we'll be here. I hope everybody will join, like in a classroom or run the exam. And then it'll be easier to answer questions. And then, we can have some discussions afterwards if we need. Some of the review points have been posted on Blackboard already. You probably have seen. Any questions at this point for the midterm? Amount of time for the exam? 90 minutes. Like a homework, you'll download the materials, work on a computer. It's open book, open to internet, open to anything, but not open to collaborations, individual work. And then you'll submit the Jupyter book. There's a video that reviews the new, kind of new, but not entirely new. The context has been familiar, but the exact data set is new. You would only have been able to see that data set during the exam, for the exam purpose. There's a video posted that you can review, to know a little bit about that data set, to save you a little bit time from the exam time, so that you're not spending too much time trying to understand the new data set during the exam. In terms of the scope, it covers until neural network, so it doesn't include neural network, but everything up to last week. But if we touch on anything that's related to logistic regression or conceptual points or the data preparation or train test play, anything hypothesis testing, they will be covered. We're going to review some of them today. And that would be the overview. Any questions? Of course, bring your laptop, bring your charger. Make sure it doesn't go out of juice. Anything else? Not much. Okay, so going forward, after the midterm exam, it's going to be the second half. The plan, the plan will continue. We'll keep the sequence. We'll cover the next module, neural network for sure. We'll start some today. But you're going to start to team up for the project. And the team is only for the project. Homework 3 and 4 are also individual work. But inside the classroom, if you are in a team, you sit close by, of course, you can talk about it. You can discuss strategies or questions. So send me, it's not urgent over the next 3 2 or 3 weeks, we can start to form teams, and then it's not urgent, right? So I think by April, you want to be, fixed with a teammate. We have small teams of 2, but we probably have 13 students, so one team will have 3. Or if you strongly prefer to work individually, which I don't encourage, but if you want to work independently, you can be a team of yourself. Or if you don't get along with your teammate, hopefully not, and that's also an option. Yeah, so send me your preference if you have, or discuss with your potential partner, have a mutual agreement, and let me know. But once you send it to me, it's going to be binding, so that you cannot seek out other teammates afterwards. If you don't send me your preferences, I'll pair you up with who I think you'll get along with. Other questions? So you all wonder about what we do today? I'm still waiting on a few. I think Pon still needs to be here. Anam is not here yet, and Hammer is not here yet. We have 10 here. Yeah, I'm missing 3. Hammer is always a little bit late because still come here from work, I think, right? But anyway, we can get started. We don't have to take too much time here. So plan for today is a pop-up quiz. How about that? To get you excited. Well, not exactly, not a quiz that doesn't go into your grades. But what I would like to do is to use today as a prep for your midterm. So there will be practice questions, and then release now, and then let's work on it as a group. Okay, and I would like a volunteer here. You'll have to come up here, but I would like to have a volunteer to work through the problem, share the screen, everybody will see on Teams, and then in the process, we'll go through points. In the process, we'll troubleshoot, we'll debug, see what kind of questions you'll see, and then review them. That's a plan. Okay, so who's going to be the volunteer? I thought about myself going through the process, but chance is that it's going to remove some of the learning opportunities for you. If I were to go through that, it's going to be very similar to last week, by which I walk through those problems. I'm prepared, it's not too much surprises, but surprises are, learning opportunities for you mostly, and especially if it's not an exam, if it's not a real exam, so it's like a mock exam, if you will, and like a mock interview is great for interviews. You get prepared for unexpected situations. So think about it. Who would like to be volunteer? You'll be on the spot. You'll be kind of under a little bit stressed, if you will, but it won't harm anything, but it will test you in terms of how much have you known about the topics? How familiar are you with the tools, and are you able to find the resources if you need. You know, but we're here to help or here to analyze. So I think it will be very unique for the volunteer, but also will be beneficial to everybody. I would recommend somebody who is confident and feeling already familiar with the course materials, if not perfectly prepared for the exam next week, because you still have a week and a weekend. But you know, just so that we run this smoothly, I like somebody who feel confident to take the lead. Anybody? I have some names I'm thinking about, so if you don't step forward, I'm gonna call you. All right, I'll let you think about for a minute. There you go. Let's talk about later. Let's talk about the exam. Sure. I think last week was very cold, I think. Now this week,
Yes.
it's like
The weather.
all right. Do we have a volunteer here? No? You just want to work by yourself quietly? One last call. Come on. It'll be fun. It will be fun. Okay. So I'm gonna say your name because now I know everybody's name. Honey? Honey. Is that right?
No problem with that. I'm not sure what should I do.
Yeah. You don't have to come up if you want. I mean, but it's not comfortable here.
Yeah.
So you better sit there. So since we have teams, once I'll have you share your screen. You can either share the entire screen or you can simply share the Jupyter notebook. And then the good thing about that is other people can see any other things going on your desktop. If you have it's something I don't want to show everybody, you will be looking through different materials in your computer, right? Because of the process. So, you know, if you share the screen, it will be helpful for everybody here to kind of see the context. But I'll give you some time to prepare for it if you want. Prepare your materials. You can open them, right now ahead of time. I'm going to release the practice test. Okay. It's going to be on Blackboard exam page. It's called Exam-1 practice set. If you join the teams, maybe it's the best to join a team, even though I have it on the screen also, but you can look at your own screen to see clearly. But also I encourage you to follow along, solve the problems simultaneously with Hani, and we'll examine problems and stop the class if you have an error that that didn't show up on the screen. So that means you had an error, which probably other students didn't have. And let's also take a look at that. Mute your microphone once you join Teams. So I'm gonna stop sharing here. Okay. And secure. Oh. Let me say a few things about the practice. So once you download the Drupal notebook, open up. So the structure and format will be quite similar, if not exactly the same as the midterm exam. The midterm exam will have slightly more questions here. We're not going to have enough time to go through as well as discuss everything if we have as many questions. But the questions will be equally challenging. There will be only a few conceptual questions. And here there's one sample question here. And then the rest of are mostly hands-on, but there are mixed type questions. Things like hypothesis testing, you will do hands-on as well as to answer questions, to analyze, interpret the results. The difference on hands-on between the practice questions and the real test is that for the real test, you'll get data sets. Here, the data sets are generated in the Drupal notebook. So it removes that process of reading the data set. But anyway, loading data set is not part of the question. Anyway, it's just a few codes that you run through like homework, But the only difference is that here you only download one file, Drupal notebook. But in the exam next week, you will download a zip package. You'll unpack the zip package and move the files into your directory, and then open that Drupal notebook in that directory. Slightly more complex. That's why, it's easier to answer questions if you take the exam here on site. But it's not too complicated for you guys, it's gonna be a peasy, you know, a piece of cake. All right, we can get started if everybody is ready. So any speaker will go through here, my speaker. I will mute myself in a second and Hani will unmute.
My No. Oh, right, so like, the international. So like, if you. Is it right to look at it?
Right,
You're welcome.
I mean, if the DP, if those things, if you know, it's. You know, keep it. You'll start to understand the read a little bit better. I can probably show on the exact point that the average started to. Like, I mean, where's the line? Sometimes you have like some say. The line is at 4. So some.
This thing is flying out on Thursday. And so I don't do Thursday. After Friday. And then I this like didn't get your mind. And then Sunday. For Saturday. I got up 6 a.m. And like right. And then there's a break in natural. It's just. Okay, so, okay.
That's the one.
Was I not supposed to tell me? Told me there's like 4 people that say people that are cousin. And that's okay. I'll tell you.
There is something. Or.
Oh, yes, I just got. I'm really good with secrets, though. So, but I think on this.
Might be the same, might be the same.
I was on your patient, but like, Jesus, and we the schedule. This should go. I can show you. Don't speak. So I just go out there. Oh, because you just put the marker. The marker, yes, the reason for the marker is it just. There we go. No, it's gonna shape these. No, this is something else. This is. Doesn't slide into last week. Okay, so now let's to show if because there was this debating if the big set.
So. I would have yes. That something. Over here, some of the potential mass.
One that's really about the 12, it's fine. That's the one use. Like, yes. Like, I'm so. So I can see the language. I did so. Right.
At this point, I don't like how. But I.
Have all the stuff.
I'll type as much as you like.
From the to the. Yes. And we was gonna be finished with the. So your doctor is kept different. And then that's what I wanted to know. That was really essentially as a. David, remind me to.
So what I'm guessing,
Okay, I just go to my.
every line starts as an issue.
Like after the doctor, right? And you're like,
What I'm gonna do.
So like I see
You know,
it down.
Different.
That's an excellent shirt. It's like.
One line, I would use a chance of minutes.
Oh, if you start, it's part of the number. Just like, it's like, it's like this one days, as my. But I was like trying
Yeah, never. From this point on. Never.
This book one is also not working. I tried again.
Okay, so we can do a few different ways. I'm going to talk about structural value. I a little bit, because that's something that is, that's not technical, but also intuitive and you can skip it a little. After that, I can talk a little about neural networks, or we can all just go on. Now, let me talk about the threshold function first. But let me know if you still need help, okay?
I want to think of what is very long. Somebody can see that one.
Honey, have you closed your notebook? Okay, if you close it, then never mind. Oh.
That's supposed to be like, I'm like. Yeah. That's not good. I'm not going from the second. I'm not going to try to read it after. After the six, we cover 6 complete for decode. This one. Either way, we have to. I know we have to go. I think we'll do that somewhere.
Okay, so what is the threshold function? Here. So in calculating the accuracy, we went through the forward process, and at some point, we had we had the activation functions. Activation functions in logistic regression, and you can think of it as the predicted likelihood of the target value being 1. So in logistic regression, after activation, the value is between 0 and 1 because it gets squeezed by that sigmoid function. So it's between 0 and 1. It's a decimal. So you can think of it as an estimate of the likelihood or confidence of the target being 1. If it's very close to 0, then you have very low confidence the target is 1. If it's very close to 1, you have high confidence the target is 1. But there are points that are in the middle, close to 5. So we use a threshold value to cut off between 0 and 1. So you know, it doesn't matter what your confidence is, we still have a judgment, you know. But the question is, how do you determine how do you determine the threshold? Here, 0.5, it's between 0 and 1. It's a middle point. Does that make sense? You know, what if it's a different model? So, that's why. And think back about this process. When we have the, let's see. When we have the W, is the weights. And right now, the weights have been updated for whatever number of epochs, right? So the WO is actually the new weights. Now that we have the model, we consider the model is ready to make predictions. You will need to go through the forward prop one more time, right? In order to make predictions. If this is score set, then this is scoring process. If this is train set, then you're just evaluating the accuracy. If it's test set, then you're testing the model. So this process looks very similar to the for loop process, the beginning part of it, because every loop process involves the forward prop and the backward prop. The forward prop, the purpose is to calculate error in order to calculate gradient, right? But how do you calculate error? What is error? Error is the distance between your prediction, from your prediction to the true answer, the ground truth, the target value. So for a case, if your confidence is 0.8, and then if the target value is 1, then the error is the difference. It's 0.2. You know, the prediction is not that close, but it's closer. It's good. So during the training step, the purpose of forward prop is to get the error and then use the error to start the backward prop and to update the weights. But here, since we're through learning, we're done with learning. We're going to use the model to make predictions. So we're only going to do forward prop. There's no backward prop because there's no learning happening. We do the forward prop all the way until we calculate the Z-act. We don't calculate error anymore here because, you know, we don't even have the true value of Y. How can we calculate error in scoring process? In training set, yes, but we don't care anymore here, since we already saved the last cost value. So even if you calculate it, it's the same, right? So the purpose is to get the activation, and then use the activation to make a prediction. So now your activation, as I said, your activation is, for any case, it's going to be between 0 and 1. You need a cutoff point to make a judgment. Is it 1 or 0? So that's the background. And so for threshold, I talked about the forward prop. So once you have the activation function, so once you have the act, is for logistic regression is going to be between 0 and 1. And recall that the Z, before activation, the Z is 3 numbers. It can be negative infinity, positive infinity. It's the net input, right? It's a number line. And at some point, it doesn't have to be 0 for Z. It can be somewhere here. Well, let's see. Zero. Sigma 0, what's sigma 0? Is 0.05. Okay. It actually will have to be 0. And this is the X. And the sigmoid function goes like this. And then it's capped by 1. So whatever your net input is, after activation is going to be between 0 and 1. That's the space of the function. The point that it doesn't happen by coincidence that at 0 point the activated value is 1/2, because Z is a function of the input and the coefficients, the weights, right? And the coefficients are learned by anchoring the activation with the target. So it's learning to align them to minimize the costs, which means to minimize the errors of the predictions. So through iteration, the weights coefficients are going to be learned in such a way that at net input value of 0, the confidence of predicting 1 is exactly 1/2. Is exactly 50%. So it happens, automatically by design. But still, when we have Z, and then we go through the sigmoid activation, we have a specific point on the y-axis, the Z activation function here. Why do we use 0.5 as a cutoff? And can we use anything else? That's something that wasn't explained when we go through the materials. So the reason why we use 0.5 is intuitive, because it's symmetric, and the space where the activated value can take its middle point is 0.5. And it's not because that the percentage of 0 and 1s are 50%. It doesn't matter. It's not because of that. It's because of the shape of the sigmoid function. That's why and also at 0 value of the net input, activated value is 0.5. And that's why. It's not because, let's say, in your data set, you have 30% target value of 1 and 70% target value of 0. And then does that mean you need to choose a threshold value of 0.3? That's not the same. That's different. That's different. The fact that you have, we call it imbalanced target values or target labels in the data set, the imbalance is going to work through the coefficients. The program will somehow learn that and then to make adjustments, but it doesn't change the way that you choose the threshold function. the threshold value here. The threshold for sigmoid function, for sigmoid activation is always 0.5. So be sure about that. But however, because it's very easy to simply, at the code level, it's very easy to simply change it. So what happens in practice is that in training process, everything, it goes according to the plan. Threshold value is 0.5. It's assumed it's not up to change. You don't change it. If you really want to change it for some reason, for some legitimate reason, you can, but you would have to revise your backward process entirely. Your gradient descent function, your gradient formula is not the same if you change the threshold function. That's all built in, So you cannot simply change here and think it works differently, because then you have a mismatch. But what happens is that because the software allows you to change a lot, in practice, analysts will simply change it and then get what they need without knowing what really happened. So what happened is in difficult problems, there's a severe imbalance between the ones and zeros. In problems, in real life problems, the percentage of one may be 5%, and you have 95% zeros in the target. So that makes a very challenge for the algorithm to be good at predicting the target, for reasons that we'll talk about later in module X, model evaluation. Because we'll introduce a number of terms, then we'll use them to explain why. But what they found is that using the threshold of 0.5, they are getting high error rates. They are getting high misclassification error rates. Their accuracy is not as high, and they are barely getting any predictions of the true target values. So there are only 5% that have target value 1, and their model, since the model is not as good, the model does not even want to predict 1. Everything is predicted negative if you stick to 0.5 error rate, because the model is not picking up credible signal to increase confidence on any prediction. So the model predicts 100% negative or 100% false on the target. So then they saw that if they lower the threshold, then more will be predicted positive, right? If all my activated values are 0.3, and if my threshold value is 0.5, everything is below that, then everything will be predicted negative. If I lower my threshold to 0.2, everything will be predicted positive. So what they do is they lower their threshold value when they do predictions, and then somehow you are able to increase positive predictions a lot. But that is against the principle. Just because it's easy to change doesn't mean you're doing the right thing. So just keep that in mind. In logistic regression, this step, the comparison between the activated value and the threshold value, and then make a judgment in terms of the target label, this is a necessary step. Once we are in the neural network, we will have 3 layers. We'll have the input layer, we'll have the hidden layer, and then the output layer. In there, it's gonna look like that. Over there, we are going to change the structure of modeling the problem. Instead of having just one target column, even for binary classification, we will have two. We'll have one column that represents positive or a label of 1, another column that represents a label of 0. In that case, when you have the activated value of the two output nodes or output neurons, you will have two confidences: the confidence of predicting positive and the confidence of predicting negative. What you do is you compare the two confidences and pick the one that's bigger, because that's the one that you're more confident about, and that's the predicted label. So in there, we ditch the idea of the threshold value, because the threshold value is not a critical part in that structure anymore. But in logistical regression, we still need that. Okay, so this is just a little bit background about that. It's not super critical to understand the everything about it, but it's important to not easily just temper with threshold value just because you can, and then that can affect the prediction outcome. You think you're on the right track, but you're not really. Trust me. So don't engage in that practice. All right, that's all. Let's go home. All right. So the exam is next week. Good luck. All right. Huh? Is it gonna be easy? Yes? No?